Hey guys, you're welcome back. Yeah, so if you're a returning subscriber, you're welcome back. But if you're a new viewer, kindly subscribe to Train Check YouTube channel and turn on the notification icon so that you can get notified anytime we upload new content. So you're welcome back, guys. So in the previous video, we talked about understanding class and objects in C Sharp. While in this video, we will be talking about OOP. We'll be talking about OOP, which is object-oriented programming in C Sharp. So basically, I will not clear this off because I might still be using it. I might still use it. Sorry, I might still use it. So let's just start. Objects oriented programming. OOP. OOP. So talking about object oriented programming. So what is object oriented programming? Object oriented programming is just a programming paradigm, right? It's just a programming paradigm centered around objects. So it is centered around objects rather than actions. So and it is widely used in C Sharp, and not only in C Sharp, in other object-oriented programming language. So it's focused around organizing your code in a way that model real world entities and relationships. So object-oriented programming is focused around organizing your code in a way that models the real world entities, relationships, and also making it modular, reusable, and then easier to manage. So following the object-oriented principle is just it makes your code modular, it makes your code reusable, and it also helps and makes your code easier to manage. You understand? So it's just a programming paradigm centered around objects rather than actions. So and also we have four principles of OOP. We have four principles of OOP. We have encapsulation, we have inheritance, we have polymorphism, and we also have abstraction. So I'll take it again. We have encapsulation, we have inheritance, we have polymorphism, and we also have abstraction. So we will take them one after the other in this video. So let's get started. So I'll be starting with encapsulation basically. So I'll be starting with encapsulation. Encapsulation. So I'll be starting with encapsulation. So what is encapsulation? Encapsulation is just the practice of bundling data. Sorry, it is the practice of bundling data fields or methods that operate on the data into a single unit. So it is the practice of bundling data, fields, and methods that operate on the data into a single unit known as a class. So let me give us an example of encapsulation. So if you check this car class, like I said encapsulation is the practice of bundling data, fields, or method together into a single unit. You understand? So this car class here is an example of encapsulation because we've grouped properties that belongs to car into a class called car. So all these properties we have name, company. So these are properties, or these are fields peculiar to a car or particular to a car, and we've grouped them together in a class as a single unit. So we group them together as a single unit in a car called class. So encapsulation is just the practice of bundling data, fields, and method that operate on a data into a single unit known as a class. So this is a car, and we've grouped all the properties related to a car in a class called car. You understand? So this is an example of encapsulation, and also this calculation class, we can also say this is an example of encapsulation because we've encapsulated together, we've grouped together all these methods. This is a method overloading, right? But we've grouped it together into as a single unit in a class called calculations. So these are just methods peculiar to calculation. So multiplying numbers, even though it's a method overloading, but we group them together as a single unit. We've encapsulated them together as a single unit in a class called calculation. So just take it that encapsulation is grouping together of a methods, fields, together into a as a single unit into a class. So let's say we also have a user service. We can group all methods that are peculiar or particular to user, like creating a user, editing a user. We can group them together. We can encapsulate them together in a class. So it helps us, like I said when I was explaining OOP, it helps us group and organize our code. That's just the reason behind OOP. So making use of this encapsulation, now you've grouped together all are like methods that are peculiar to calculation. Let's say we have more than add number, divide number, subtract number. We group them together inside this calculation class. So it helps us group our code. We already know, okay, if you want to go and edit any method or add a new method that is particular to calculation, we just go into the calculation class, do whatever we need to do, and we move out of it. So we already know we've grouped together every method that is particular to calculation, and also this car class. So let's say we want to extend or we want to add or remove anything from the car. We can just go, okay, we already know we have a car object or a car class, then we can just go there and do whatever we need to do. So you understand. So that is what encapsulation means. So I might not really be doing, so I think I already used this as an example for encapsulation. So and this, so they are all example of encapsulation. So moving on to the next, I'll be talking about inheritance. Inheritance. So inheritance. So what is inheritance? What is inheritance? So inheritance is the mechanism by which a class. So it's the mechanism by which a class called a derived or a child class, right, acquires properties and behavior, or acquires the properties, behavior, or methods, right, from another class called the base or the parent class. So what this does is just it promotes code reusability, allowing new classes to adopt and extend the functionality of an existing class, right, without rewriting code. So that is just what this does. So like I said, inheritance is the mechanism by which a class called a derived or a child class, right, acquires properties or behaviors or a method, right, from another class called base or parent class. So I'll be using this as an example. I'll be using the animal and a dog, animal class and a dog class as an example. So let's say we have a class called animal. So this is an example of this is basically an example of inheritance that I want to do now. So let's say we have a class called animal, right? We have a class called animal that has a method called it in it. It has a method called eat. So we all know that animal can eat basically. Animal can eat, right? So then we say eating, right? So we all know animal can eat, right? Because yeah, animal can eat basically. So this is a method called eat in animal, and then it is doing what it is called, so writing eating. So let's say we now want to create another class called dog. We all know that dog is also an animal, right? You can create a method called cat, a method called lion. We all know all those stuff are an animal, right? So let's say we have a method called, we have a new class, right? We want to create a new class now called dog. Dog is an animal, right? Okay. So, and we want this dog class to have access to this method called it, because we already declare a class called animal that has a method called it. So we can't come down here again and now say, okay, we want to rewrite this or we want to redefine this inside the dog. This is what we are repeating code like this. We are rewriting code, and we don't really need to rewrite, since there is a principle that say we can actually make use of inheritance, right, to have access to whatever implementation or whatever method we have in a parent class or a parent class, right? So instead of doing this, we can just say, okay, let this dog class inherit from this animal class. So dog is inheriting from animal now. So dog has access to this method called it in it already because we are already inheriting from this animal class, right? So if we do this now, if we do, let me just copy this guy. So if we do this, so um dog, let's say new dog or anything. So okay, so okay, it must come before. Let's just take it to the top. It must come before the class declaration. Yeah, so here now we have the so now we dog already inherit from animal, right? Dog already inherits from animal. We don't have any method inside this dog. But if we do this new dog dot, you can see we already have access to it because dog is inheriting from animal and animal has a it method in it. So it's according to the definition of inheritance, it says inheritance is the mechanism of what by which a class called a derived or a child class acquires properties and behavior or method from another class called a base or a parent class. So this dog is the derived class or the child class, right? And why animal is what? Animal is the base or the parent class. So according so it says this promotes code reusability, allowing new classes to adopt and extend functionalities of existing ones without rewriting codes. So we already acquire the functionality of animal class in dog without rewriting the it method. We acquire the functionalities and the method inside animal class in dog by inheriting from it without having to rewrite this it method in dog class. You can see. So let's launch this. Let me remove this back. So if I do dot it, and let me just comment on all this console dot write line because it will also write to console. And I launch this, you see it will write it into the console, which is dog.it. You can see eating. So dog is inheriting from animal to make use of the method called eat that we have inside animal. But dog can also do what? Implement or create its own method or have its own methods. I can say public void back because we know back it's only dog that can back. You can have a unique method called eat because all animal can eat in one way or the other, but back only dog can back. Only dog can bark. So a cat cannot bark, any other animal cannot bark, but a dog can bark. So you can do this saying barking. So you can see, and we can also have access to the barking new dog. But you can see barking back. Yes, okay. I have to end it with a semicolon. Sorry. So you can see eating backing. So it helps in it helps organize your code. It helps in reusing another block of code because if you want to if we don't want to follow the OOP principle now, we don't want to make use of inheritance and every other thing. Since we already have this it inside animal, if we don't want to follow the we just come down here, copy this, and also now put it back inside this place and say, okay, we want to have it. But following the OOP and then making use of the inheritance, you don't actually have to repeat yourself. So there's also a principle called try. Do not repeat yourself in programming. So you don't have to repeat yourself. You just have to make use of the principle and then inherit, and then you move on with whatever you want to do. So that is all about inheritance. That is all about inheritance. So moving on to the next, we have um polymorphism. So encapsulation, we've talked about encapsulation, we talked about inheritance. So now let's talk about polymorphism, and also we will talk about abstraction. So polymorphism now. So polymorphism, let me just write this down. So polymorphism allows objects, right, of different classes to be treated as instance of the same class. So polymorphism allow objects of different classes to be treated as instances of the same class, right, through a common interface. So this can be achieved by two ways. Polymorphism can be achieved by two ways. So polymorphism can be achieved by method overriding, which is the runtime polymorphism, and also method overloading, which is the compile time polymorphism. So enabling the same method to perform different tasks based on the object that invokes it. So polymorphism can be achieved in two different ways. We have method overriding, which is the runtime polymorphism, and also method overloading, which is the compile time polymorphism. We've talked about method overloading before. Yeah, so method overloading is an example of compile time polymorphism, right? Why method overriding is an example of runtime polymorphism. So, like I said, polymorphism allow objects of different classes to be treated as instance of the same class through a common interface. So, I'll give us an example of polymorphism right now. So, polymorphism. So, I'll start with a compile time polymorphism, which is the method overloading. So we already did something about something on method overloading in our previous video when we were doing class and objects. Yeah, I think it was previous in our previous video, which is class and objects. So if we come down here, this is actually an example of what? This is an example of polymorphism. This is an example of polymorphism, which is a compile time polymorphism, right? This is an example of a compile time polymorphism. So compile time polymorphism is different methods, making use of a method overloading, right? Where different methods can have the same name but different parameters. This is the same name, this is the same name, this is the same name, but different parameters. So this is just an example of a compile time polymorphism, right? This is an example of a compile time polymorphism. Why we also have runtime polymorphism. So what is runtime polymorphism? Runtime polymorphism is when a derived class can override a method. When a derived class can override a method of its base class to provide specific functionalities. That's what we called runtime polymorphism. When a derived class can override a method or a method of its base class to provide specific functionalities. So I'll give us an example of, since this already covered an example of compile time polymorphism. So let's now talk about runtime polymorphism. So runtime polymorphism is method overriding, right? So I will do this as an example. So let's say we have a class called shape. We have a class called shape, right? That has a method called public virtual void draw. So we have a method in shape called draw. This is our method signature. So, and what this method is basically doing is what? Drawing a shape. So I'll just say drawing a shape. drawing a shape. So with runtime polymorphism, which is method overriding, we can actually create another class and another method to override this shape class and the draw method inside the shape class, overriding it and then using it to do to implement our own, or to provide our own new functionalities. Let me just put it that way. So I can create another class called circle. Circle is what? Circle is a shape, right? Just like when we were doing dog and animal. So circle is what? Circle is a shape. So I can say circle should inherit from what? From shape. Circle should inherit from shape, right? And then circle should override this draw method that we have inside shape to implement its own functionalities. So I can say public override void, which is draw. So we have a method called, you can see draw, you can see. So we have a method. This draw is actually coming from this shape, this class called shape, that has a draw method in it. So I'm overriding inside circle class now. I'm overriding this method called draw that we have inside shape. I'm overriding it because what this method called draw in shape is doing is just drawing a shape, right? But I want to override the draw method to to from drawing a shape to just drawing a circle. So shape is what? Circle is also a shape, right? So and we have a method called draw in it, which is drawing a shape, right? I want to override this shape, this draw method we have inside shape, from drawing a shape to drawing a circle. So polymorphism of runtime polymorphism is what we call method overriding, right? So this is what I'm trying to practice here. So I can now say public override this, and then I will do this, drawing a circle. So with this, I already override this draw method, which is basically drawing a shape, towards drawing a circle. You can see this. So if I do this now, circle new circle is equals to new circle, then I do new circle dots, you can see draw, new circle dot draw. Instead of this writing out drawing a shape to the console, it will write out drawing a circle because I already override this method called draw that we have inside shape. So if I launch this now, you can see drawing a circle. So let me comment on this too. Sorry. So you can see drawing a circle, drawing a circle. But if we come down here and we do this guy, shape, circle is a shape, right? So we are overriding the shape class to draw a circle. So if I come down here and I do this, new shape is equals to new shape, right? And I do new shape dot draw. If I comment on this guy called circle, you see this will write to the console drawing a shape. You can see drawing a shape. So but with method overriding, I override this drawing a shape method that we have inside shape to draw a circle instead of what? Instead of shape. So I can also do the same thing for, let's say we have, instead of circle we have triangle. Triangle. So I can also say drawing a triangle. also say drawing a triangle, which is basically, sorry, drawing a triangle, new triangle, new triangle, and you will see it will draw triangle. You can see drawing a triangle. So that is what polymorphism is all about. So polymorphism allow objects of different class to be treated as instance of the same class through a common interface. So this can be achieved by what? Method overriding, which is the runtime polymorphism, which is what we just did now. This is the runtime polymorphism, which is method overriding, and also method overloading, which is the compile time polymorphism. So polymorphism allow us to do what? To treat this triangle and to have access to this method draw inside this triangle as if it is our own method, or as if it is the triangle method. So the method actually belongs to what? Belongs to shape, right? The method draw belongs to shape, which is drawing a shape. But polymorphism allow us to do what? To make use of the method called draw inside the circle as if the method to circle circle. Then it allows us to override it and make use of it to draw our own shape, which is circle. So do the same thing for triangle. Drawing a triangle, you can also continue to do the same thing for anything you want to use it for. So that's just what polymorphism is all about. So if you don't understand it, or you want me to re-explain, or you want me to or you there's something else you want me to, just drop your question in the comment section. I will attend to each and every question. So moving on to abstraction, which is the fourth one. So we've talked about encapsulation, we've talked about inheritance, we've talked about polymorphism. Now we are going to talk about abstraction. Yeah, so abstraction. Abstraction. Yeah, so what is abstraction? Abstraction is the concept of hiding complex implementation. So it's the context of hiding complex implementation details and exposing only essential features to the users. So make use of abstraction, you hide the main complex implementation details, and you only expose the essential features which you want to expose. So in C sharp, abstraction is achieved through abstract classes and interfaces. Yeah, so abstraction is achieved through abstract classes and interfaces in C sharp. Yeah, so I'll be starting with the abstract classes. So abstraction can be achieved, like I said, abstraction can be achieved using abstract classes and interfaces in C sharp. So an abstract class cannot be instantiated and can contain abstract method that must be implemented by derived classes. So performing abstraction using abstract classes. So let me just state an example of how to implement abstraction using abstract classes. So like I said an abstract class cannot be instantiated. So you cannot instantiate an abstract class just like the way we are instantiating all this. Triangle is a class, but assuming it is an abstract class, we cannot instantiate them just like the way we are instantiating all these normal classes. So that is that for that. So abstract class. So let me just give us an example of how we can implement abstraction using abstract classes. So I'll create an abstract class for an vehicle. So like I said uh, I said abstract class cannot be instantiated, and an abstract class can contain abstract method that must be implemented by derived classes. So an abstract class can contain it can contain an abstract method that must be implemented by derived class. So we can have an abstract method. So just take it that this abstract method we are having inside this abstract class, can be implemented by the derived class, which is the derived class is the class inheriting the abstract class. So abstract method. So I will not say draw this time around, I'll say start, because you can actually start a vehicle. So and then you can also have another method called stop. So you can start and stop a vehicle, but this will not actually be an abstract method. And yeah, so I can actually do this and console write vehicle stop, vehicle stop. Sorry. So this is an abstract class that has an abstract method called start and a normal method called stop. So to make use of an abstraction using an abstract class, we can create another class called car, which can actually be a normal class, C# class called car. So this this abstract class vehicle, it has two methods called start and stop. So to um to make use of abstraction using an abstract class, we can create another class called car, which can inherit from this guy called vehicle, and inherit from vehicle, right? So you can see this is actually giving us a red sign because it says cars does not implement inherited abstract member vehicle dot start. Because we already declared an abstract method inside this abstract class, this car class must actually implement this start method. Because if it does not implement the start method, we will actually get an error. So that is why we are getting this error, that car does not implement inherited abstract method called vehicle start. So if I change this from an abstract method, you will see, yeah, basically this will not actually give us an error. You can see. Since we already have, so like I said in the explanation of the abstract class, I said abstract class cannot be instantiated. That's number one. And abstract class can contain an abstract method that must be implemented by the derived class. So car is the derived class, right? So any abstract method you have inside this abstract class must be implemented by this car, this derived class called car. So that is that for that. So you can now say you can actually override the method to, because this is just a void method that does not even write anything or that does not even implement anything. So we can override it to determine whatever we want the method to do. So public override sorry, that's 3R, override void start. So you can see, so which we can actually say, you can just copy this guy and say vehicle, or yeah, sorry, car, as car started. So you can see it is no longer throwing any error because this derived class, which is the car class, has already implemented this abstract method that we have inside this vehicle class. It's already implemented this method that we have inside this vehicle class. So you can see we no longer have, it is no longer showing us error. If I should comment on this guy, you will see it will show us car does not implement inherited abstract member vehicle.start. So if I can actually instantiate this car class. Oh, I already have a car class right here. Let me just comment on this guy. So I have a car class before. Yeah. So let me just comment on that one. So at this car, I can now declare instantiate this guy here, this car here, and say new car then you can say new car dot start. Then you see it will write to the console car starting. So let's wait for the, you can see car started. Yeah, you can see car started. So according to what I said before, I said an abstraction is the concept of hiding of complex implementation details and exposing only essential features to the user. Only exposing the essential features you want to expose. So with this abstract class that we did right here, we already hide this implementation of a vehicle inside it. So this is an implementation. This start method is an implementation. Why this stop is what is also an implementation. So we already hide this guy or this method here, and we only expose the one that we need. We expose this start because we want to override it. That's why we only expose it. So we can also have access to stop. So if we do this, if we do new car dot, you can see stop, right? Stop. Then we can launch this. You see vehicle stopped. You can see vehicle stopped. So we only expose this start method that we have inside the vehicle. We only expose it to car because we actually want to override the method to implement what we want it to implement. So we only expose the essential features to the car. The essential features of vehicle, we only expose the essential features of vehicle, which is start, to the car, which the stop is still inside the vehicle. We don't expose it to car, but still car has access to the method called stop. You can see has access to stop, but we did not expose the stop method inside car, right? But I still have access to it. So that is abstraction. We abstracted this method called stop, and then we still have access to it inside car since we already inherited it, and then yeah, since we already inherited it. So that is abstraction using an abstract classes. So like I said, I'll come again. I said abstraction is the concept of hiding complex implementation details and exposing only essential features to the user. So we hide this implementation. So we have two implementation. We have start and stop. So we hide the stop implementation from car, but we only expose start implementation, which is the start method, to car because we actually want to override the start method to implement whatever I wanted to implement inside car. But we still hide this stop implementation from the car, but still we have access to it because we already inherited the abstract class, which is this. That is what made us has access to it. So that is abstraction using an abstract class. So we also can also perform abstraction using using interface. So this is abstraction using abstract class. So you can also perform abstraction using interface. So let me start with the definition of an interface. So what is actually an interface? So an interface is a contract between a class and itself. So an interface is a contract between a class and itself that defines a set of method. So an interface is a contract between a class and itself that defines a set of methods, properties, events, or indexers that a class or struct must implement. So an interface is a contract between a class and itself that defines a set of methods or properties that a class must implement, right? It specifies what a class should do, but not how the class should do it. So an interface will tell you, okay, this is what a class should do. This is what a class should do, but it will not tell the class how it should actually do it. Just tell the class, okay, this is what you should do. But I'm not telling you how you should do it. You can do it anyhow you want it, but this is actually what you should do. So just take it like an interface is a contract between a class and itself that defines a set of methods properties that a class should implement. It also specifies what a class should do, but not how the class should do it, as it contains no implementation, only what? Only declaration. So interface only contains declaration. It does not contain implementation. It only contains what? Declaration. So let me show us an example of an interface. So let's say we have a class. We have a class called robots. We have a class called robots, right? Robots. And the class actually have this method called, because robots can move basically. So let's say the class has a method move called move, right? Since robots can move, so we have robot is moving. Robot is moving. Robot is moving. So to make use of abstraction using what? Using interface. To make use of abstraction using interface, like I said interface is what? Is a contract between a class and itself, where interface so I said interface is a contract between a class and itself, where the interface defines the set of method properties that a class should implement or a class must implement. So and I said it only contains declaration and it does not contain the implementation of the class. It only contains the declaration and not the implementation of the class. So to make use of an interface, we can actually create an interface called, what should I name it? Okay, let me name it public. So to declare an interface, you make use of this keyword interface, and I can say iMovable, or maybe iRobot or iMovable. Yeah, so let me just make use of iMovable, right? iMovable. So and then robots can inherit from iMovable. Why iMovable will now have the implementation. Sorry, I said the implementation. We have the declaration and not the implementation. Class, we have the full implementation, but the interface will have just the declaration of the method. So where this we now have this, we then have this. You can see. So interface only have the declaration of the methods the class is having. So like I said interface will tell the class what it should have, but not how it should have it. It will tell the class, okay, like this iMovable is telling this class, you must have this move method, but I'm not telling you how you should implement it, but just have the move method. So if I change this move now to something stop, you can see the interface is now showing red that robot does not what? Implement interface member move. Robot class does not implement interface member move. So an interface is telling a class what it should have, but not how it should implement it. This iMovable is telling this class, a robot, you must have this move method. I'm telling you must have it, but I'm not telling you how you should implement it. Just have it. So since it is not having it again, that's why you are getting this error. But if we should change it to what? To move. You see, there is no error. There is no error. But we can also have stop. Robot stop. So we can have stop. If this interface does not have if this interface does not have the declaration of this stop, it will not actually make any error. It will not throw any error because it does not have, only the class know that okay, I have this stop, but the interface does not even know that the class is having the stop, right? But once we put this declaration of stop inside this interface, right? Once you put this declaration of stop, the declaration, declaration of stop inside this interface, and we now change this stop to go, it will tell us robot does not implement interface member stopped. So whatever declaration you have inside this interface, you must have the implementation inside the class. So interface is telling the class, this is what you should have, but I'm not telling you how you should have it, but you must have this. So if I change it back to stop, you can see. So this is abstraction using interface. So this is abstraction using interface. So for us to hold all this method now, for us to call all this method, so we want to make use of all this method inside this robot class. You don't have to actually instantiate this or create a new instance of this robot class again. You can just make use of this interface to have access to all this move and stop method. Just like the way we are instantiating this car class to have access to the stop and start method. We don't have to instantiate, since we are already making use of interface, we don't have to instantiate this robot class to have access to the move and stop method. We just make use of this just make use of this interface. So to do that, to actually make this work like as in the standard and the expected way, assuming we are in the framework, we just make use of dependency injection. We inject we inject we inject this movable in the constructor of the class where we want to use it. You get? So we inject it in the constructor of the class where we want to use it. So let's say we want to use it with this something, let me see, or let's just create a new class and we make use of it inside the new class. So let's create a robot service class. So we make use of this robot inside the robot service class. So public class robot service. So to make use of this interface, to make use of abstraction using an interface in this robot service class, so we have to make use of what we call dependency injection. We will still get there. Once we enter the framework, we will understand what dependency injection is. So I'll just do it so that we can make use of this interface the how it's supposed to be used. So to make use of this, we have to generate a constructor. So I can just do control dot. So if you click on control dot, you will see generate constructor. Yeah, so let's see, control dot should actually generate a constructor. Okay, if this does not generate constructor, we can just generate the constructor by our, sorry, remove this guy. So this is a class, yeah, sorry, that is, so generate constructor, you can see, generate a constructor. So this is how the constructor looks. This is what is called constructor. So whatever we have inside this constructor is what will be executed first whenever this robot service class is being called. So whenever this robot service class is being called, whatever we have inside this constructor is what is going to be is what is going to run first. So before any other methods we have inside the robot service. So to make use of the movable interface inside this robot service class as an abstraction, so you just create a private a field here, so a private field. So you can see private read only movable, and you can just do this, and then if you do this, you'll see, if you do control dot, you will see add, you can see add parameters to robots, you can see. So this is how to make use of dependency injection. You can see we declared the iMovable as a private field, and then we inject it inside the constructor of the robot service class. Inside the constructor of the so whenever this robot service class is being called, this is what is going to be executed first. So this is going to be executed first whenever this robot service class is being called. So for us to have access to all these methods we have inside this robot class now, in this robot service class, we just do movable dot can see. Sorry, let me just do this. Just do movable dot. Sorry. We have to create a method. So let's just create. We have to create a method public void. Let's just say you can call it a random name. Testing robots. Let's just give it a random name. So let's give it a random name. So for us to have access to all these methods we have inside this robot class, so we just do movable dot. You can see we have access to stop. We also do movable dot. We have access to move. So this is how we make use of abstraction using an interface. This is how we make use of abstraction using an interface. So we've hide all the full implementation of this robot class. So all this full implementation, which is the move method, the stop method, we have inside this robot class, hide the full implementation, and we only expose what we want to use at that particular time. We can decide to remove the move and decide to use the stop only. We can decide to use the stop to remove the stop and make use of the move only. So we've had all this full implementation. Even this robot service class does not even know that a robot class actually exists. It does not know a robot class. The only thing it is seeing is this interface, and the interface is feeding it with what it needs to use at that particular time. So we can actually extend this guy to have more methods. We can have run. Then we add we add the declaration inside this place, as the interface only contains the declaration. So interface only contains the declaration and not the implementation. So yeah. And once we do that, we will have access to both. Sorry, we will have access to can see movable. We have access to can see run. Now have access to run. Can decide to make use of run. So with abstraction, using an interface as an abstraction, we've hide the full implementation of this robot from this robot service class. Robot service class now does not even know maybe a class called robot exists. The only thing it is saying is iMovable, which is the interface this robot service class is implementing, is inheriting from, is implementing. So only seeing the iMovable class, iMovable interface. So this is what we called this is what we call abstraction using interface. So this is what abstraction using interface is all about. So we've hide all the full implementation of this robot class, and we only expose what we need at that particular time to robot service class using an interface called iMovable. So we've talked about abstraction using abstract class, and now we've talked about and I've explained abstraction using interface. You can see the difference between the two, between the interface and the abstract class. So that is all about OOP. So that's all about OOP, object-oriented programming. So we've talked about encapsulation, inheritance, polymorphism, and now abstraction. So if there's anything you do not understand, or if there's anything you want me to explain more, if there's anything you want me to explain again to you, you can kindly drop your question in the comment section. I will attend to each and every question. So guys, don't forget to like this video, don't forget to subscribe to Train Check YouTube channel, and don't forget to turn on the notification icon so that you can get notified anytime we upload new content. And also guys, don't forget to share this video. Thank you guys. Like I said earlier, if there's any question or anything you don't understand, kindly drop them in the comment section. I will attend to each and every question. So guys, thanks for joining. See you in the next video.